Hello, Girls Inc. My name is Steve Dellenback, and I am representing the Intelligent Systems Division at Southwest Research Institute today. I'm very disappointed that we can't be together in person, but I wanted to spend a few minutes this morning with you talking about various robotic projects that are going on right here in San Antonio. We are currently developing a number of automated vehicles. To date, we've developed over 20 different automated vehicles for both on-road applications and off-road applications. In the United States, only about 2/3 of the roadways are paved, so off-road is very important. Most of you probably heard of the Google car or the Waymo vehicle, which is the best in class in working on-road. This is an example of a military vehicle doing off-road autonomous driving. This vehicle does not have GPS and it does not have a map. And so we've told this vehicle to go the other end of the field, and it's literally feeling its way through the environment. It's looking at the ground, it's looking for grass, rocks, trees, and developing paths to go around it. This is what the computer actually sees. That's the image up on the upper left of the camera. The computer vision is on the upper right. And then the bottom is the path planning that's going on. It's actually guiding the vehicle. This is an example of a different type of automation. This is taking an automated 18-wheeler and doing automatic backing and parking operations. When we look at where we can use autonomous driving, if we can get away from the crowded roads, we can get this stuff out in the field and deployed much sooner. So this is an example of a highly repetitive task. It's highly precise, and this vehicle will park within about 2 centimeters or less than an inch of the docking platform there. This works well in environments, again, where there's not a lot of other vehicles out or pedestrians, etc. This is an example of a tracked vehicle it's military in nature, and it's fully autonomous. It can go approximately about 30-35 miles an hour. And this uses a wide variety of sensor technology to sense the environment and where it's going. Another area of robotics that we work on is more traditional manufacturing robots. We call those our big orange robots, and I'll come back to those in a minute. Here's an example of a robotic system we developed for the military. This is to paint military vehicles. And what you find is each military vehicle might be slightly different than another because they bolted on different equipment, different weapon systems, etc. So in this robotic system, the vehicles are actually come into this facility, and the robots do what we call scan and plan. They actually will scan the entire vehicle and then develop a paint plan that is specific to that actual vehicle. And then you can see here that it actually applies the paint. The benefit of the system is we can do these systems much faster than they can do them with using human beings, about twice as fast. The next is an example of what we call a collaborative robot. In traditional robot space, you normally fence off robots because they're very dangerous. These next generation have sensors in them that if they hit somebody, they'll actually stop immediately. We also use this type of technology. Look closely at the wheels on this robot. These are called omnidirectional wheels, and they allow this robotic platform to go in any one of 360 degrees orientation. So it can spin on its center axis, and it can get very tight access to whatever type of vehicle it's working on. Over on the right-hand side, that's a picture of the big orange robot, about 22 feet tall. But I want to talk about the robot on the left that you see there. This is for using laser technology to strip paint off of aircraft. This is a 600 frame per second video, so it's a very fast video showing us using a laser is actually vaporizing the paint off the airplane. The reason we want to take paint off an airplane is so that we can see if there's any cracks or surface problems. That's a picture of the actual robot, and here's the robot actually working on a Boeing 727. This robot's approximately 65 feet tall, so it can rise to the top of any aircraft. And it weighs approximately 160,000 pounds, so a little over 80 tons. And you can see here, this is the operational speed of it. In this particular video, we're not using a laser. We have a limited number of aircraft that we can take paint off, so we're actually just perfecting our motion robotics and our kinematic plans, etc., as we move forward on this. This is an example of using some of our advanced vision technology and our machine learning technology to improve sports. What we can do here is we can actually track objects, we can track baseballs, we can see how fast they're spinning, how accurate. We can also, without putting specific markers on people, we can marry skeletal models that we have and determine how efficiently is an athlete actually using their body and how good is their repetition, because a good service, for example, is a highly repetitious move. I want to thank you today for coming and listening, and I hope you have a wonderful rest of your weekend.